Okay, let's get started.
America.
It's America. So today we're going to talk about probably one of the most important design patterns that you will encounter all the time if you continue on with your programming. The model view controller, which is basically, well, it separates all your program into three parts. Can you tell me which parts those are?
I'd say, the intro, the body, and the
Conclusion. Yeah, that sounds great.
Thesis statement.
No, good. Thesis statement. All right.
Essay.
Yeah, essay.
I'm gonna have to say there's an interface somewhere.
There's an interface somewhere. Where do you think the interfaces are? They're the dashes. So between the model and the view, and between the view and the controller, there's actually one between the model and the control. Anyways.
Yeah, okay.
All right. So,
I'm gonna say there's the model, the view, and the controller.
all right. So it separates your program into three parts: the model, the view, controller. The response. Oh.
That
Oh,
makes a lot
yeah.
of sense. Yeah.
The view is basically the GUI front-end paint. The controller is the commander or the master telling everyone what to do. And the model is the grunt that does all the work. There's your high-level explanation. And now we will spend the rest of the class talking about that. So the hard problem, So I copied some of these slides, but a hard problem in OOP is deciding basically the roles of each object. What are their responsibilities? What should each one do? Nice thing about design patterns is that if you study design patterns, and there's a lot of them, they will try to tell you what roles you should assign to different classes, so they can actually give you examples and ideas of what to do. Yeah, so design patterns, a major topic. MVC is perhaps one of the most widely used design patterns out there. So it stands for Model View Controller. The model is the actual internal representation. It usually is modeling the data, holding the data, manipulating the data, doing whatever you want to with the data. The view is just a way to look at it, or it's the view into the data. I see. So that's usually where your GUI is. The controller provides user input and modification. Essentially, because in reality the user is the controller. So the controller is basically taking input from the user and deciding, okay, you need to do this model, go do that, and then view, make sure it displays properly. That's the connections. Usually they're implemented as separate classes, yes?
Data is pronounced both ways.
Yes.
It's
Yes, it's pronounced both ways, but I'm correct.
like the dictionary gives two different pronunciations.
Yeah, I agree, but I'm correct.
No matter what.
Right.
Regardless.
So the three components are usually implemented as separate classes. You may also have more than one controller, more than one model, more than one view. Well, you should have at least three classes when you're doing MVC. Let's see. This is just talking about MVC actually came about before GUIs were super popular. And that was when you had text. It just happened to also fit like a glove when GUIs came about, in view. So this MVC has actually been around for a while. I think it came out in the 70s. And they've just been
So did they design GUIs for view then? Or did it just, it just worked?
GUIs were, wait a minute, people like pictures.
Oh,
and then they were trying to, MVC was, they already had MVC for, your view was basically the text being spit out, is really what it was. So they just said, okay, we'll just change the view to be a GUI and go from there. But then there's also WIMP, windows, icons, mouse, and pointers or something. Printers, yeah, I can't remember the last one. There's a lot of other GUI things running around. There's plenty of acronyms. We got more if you need them.
yeah, please. Not like I already have to learn a lot.
No. So the controller decides what the model is to do. So it's the commander or master, but doesn't know how to do anything. It doesn't want to dirty its hands, but it just tells everyone what to do.
It's Donald Trump.
It's Donald Trump. The controller is Trump.
That's correct on many ways.
Yes. All right. Yeah, the user is put in control by means of a GUI, so then the controller is often the same. Sometimes the GUI, part of the GUI is the controller, aka a button might be part of the controller because you click the button that's commanding the program to do something. when you design the controller, it does depend on how it interfaces with the model. But the model should never depend on the controller, because the point of all this is to make the model so you can work on just the model to figure out how you should do the heart of the program, actually manipulate the data. And then the controller and view are kind of almost around it to help out. So the view, basically how you look into it, it shows what the model is doing. So the controller tells the model to do something, the model may make a change, and then that change will update the view, and the view will need to reflect what change happened inside the model. So it's usually a passive observer. It should not affect the model. Let's see. Right, so the model needs to be independent of the view. And the view should never think about the controller, really. It should not display what the controller thinks is happening. The view is really tied strictly to the model. Wow, okay. Sometimes people will try and combine the controller and the view, and this can make sense for very small GUI applications. But make sure your model is always independent. In other words, never mix your model code with your GUI code. All right. So, which part of Solid does this sound like?
Single responsibility.
Yes. Yes, this is definitely single responsibility principle to the extreme. All right, so you want code independence? So there we go. What is it? Should not contaminate with control code. The view should represent the model. The controller should talk to the model of the view. Ooh, this would have been a good time for a picture.
Picture of what?
Well, you know how we like to have boxes.
Oh, okay.
You know about boxes. Boxes,
This
right?
one right there.
This is just a giant box. Let me get my eraser. And wow.
Everything over there. Oh. What you found? Closer one. It's a blue one, I bet.
Okay. So you have your model, and that may have your data. We'll just say
Data.
data. Now, you may have your controller down here. And let's see, and then your view would be over here. So the controller basically, I'll just write the word commands. And then the model would basically update. Command a change to the model does a change to the data, which then updates the view. All right, so your user might request a change. So this is a very high-level idea of what's going on. User puts a request to the controller says, okay, model is what you need to do, model changes data. The view says, oh wait, the data's changed, so updates the view so that the user can see the change. High level of what's going on. No remarks about my stick figure or
It was
anything?
beautiful, John.
Beautiful, thank you.
You could
Thank
use
you.
a smiley face.
Okay, all right.
Maybe a head of hair.
So I think so let's give a very simple example. This is called a reverser program. Basically, you type some text into the text box, you click reverse string, and it reverses the string for you. Whoa. All right. Obviously, we don't need to do MVC for this example, right? This is pretty straightforward what's going on. But I'm going to go ahead and separate this out completely into a model, view, and controller, separate classes, just to solidify what's going on. So first off, the view. Notice the view is basically handling a lot of the GUI, because you have, up top you have your text box or your text field that actually has the text field to hold the text. Notice I made that public, which is okay because that's an object. So other people, if they have access to this class, can have access to that field. And then inside of start, I make a vertical box, create the text field, add that to my vertical box, create a button. Notice I'm going to set the on action by getting the controller. So notice the first hookup here is that the controller is going to be notified when someone clicks on the button. That's because when the user clicks on the button, they're requesting the change. Then I add that button. And also notice right here that we're informing the controller of the view. It is normal most of the time, well, sometimes to have the controller have access to the view. In this case, it makes a lot of sense because there's a connection here where the GUI is doing both the commands coming in and then viewing it out. All right, the controller. Let's see, do I have anything else here? All right, controller. Right up top, I'm using a singleton pattern. Basically, there is going to be only one controller. The way we do this, private static of the controller, and then you can always call the static function get controller. And basically, whenever you call get controller, if there isn't one, it creates it and then returns it. Otherwise, it just returns it. So that way, there's only one controller. Notice that the controller does have access to both the model and the view in this example. That is common to have it done that way, although not classically correct. But this is common because I think it makes it simple, at least for this example. Notice that when you create the controller, it goes ahead and creates the model. That way you actually have a model. But the other thing is, keep in mind the controller is the commander, so it has the controller itself has access to the model and access to the view, because it's what's telling everyone what to do. And I call set view here just so that it will have access to the view once the view is created. And notice that the controller also, I really should be using my mouse pointer for all your online students, has a handle, because notice the controller implements the action handle, that when it receives a click, all it does is it tells the view to update itself based on what the model says your new data should be. The key thing here is the controller is not doing any of the work. It's just saying, hey, look, view, update yourself, because the model is about ready to tell you what to update. So it's forcing the view to update. And then, of course, down here we just have it launch. Okay, is this making sense? I feel like I'm cruising through this really fast. A little bit? Okay. So the model, it's actually pretty simple here. It gets a string, it reverses it, and then returns it. It's really helpful since String Builder has a function called reverse.
What's cheating?
How is that cheating? It's not cheating, it's using my resources. But if you say that on an exam, you get an F, okay? Just keep that in mind.
Well, isn't it the same thing?
What about if
Like,
we
this
cite
is
it?
technically a test.
What? Cite what? Oh, if you cite it, then you won't be expelled from the university, you'll just get an F.
But points for trying.
Sure, I might give you a pity point. I like pity points.
All right.
I've always wanted to give someone a 1 on their final exam.
I'll be the first guy.
I got a 0.
So I went ahead and wrote this morning. Let's see, we're at the controller.
Did you copy and paste it?
No, I wrote it. Because where I copy and pasted from was in Java Swing. And I was like, oh, failure. So what string do you want reversed? Quick.
Paul of the West.
Paul of the West.
Dog would have been better.
God. Race car, do race car.
Yeah, that's that's funny. Oh wait, that writing in the code. Oh, that'd be bad.
Woo!
Oh, it's not doing anything.
Palindromes. Yay, palindromes.
Question.
That way you can see that's being reversed. Whoops. All right. So hopefully you can see how things are at least somewhat separated here. Man, we're just going to cruise through this today. All right.
Good. I'm gonna need a lot of help.
You're going to need a lot of help? All right. Yeah, any questions about this example? The view, mainly the GUI, knows that it tells the controller that it exists and makes sure that it hooks up the controller for anything inputs that are coming in from the user. At least in this case, the controller, it has access to everyone and can tell everyone what to do, but it doesn't know how to do anything. And the model does all the heavy, it does what it's told. It's not Trump at all. What would it be in this case? Hillary. Ouch.
What happened?
So Trump's the controller because he tells everyone what to do. The model has no command power, but it's able to do anything.
His wife?
That's the Congress. That's Congress.
No.
She's married.
Okay, sure. So he's the
Obama.
VP.
That's Obama.
Okay, it's Obama.
Oh, it's Rockefeller.
Rockefeller. There we go. Rockefeller.
It's the newest. It's the newest Rothschild
Okay.
since the old one died. Finally, after 9 heart transplants. I don't know if it was 9. It was a few. It was.
He had more than one?
Yes, he had more than
Who
one.
is this?
At least 3.
He's not. Now you're saying 3. Maybe it was only 1.
I said at least 3.
Wow. I don't know how it feels to have a heart transplant.
He's been a different person.
All right. So I'm going to go through a couple of example architecture. 6. I don't think I can live with myself in that point.
2 kidneys and 6 hearts.
2 kidneys.
You're taking away so much from other people. Just like,
Yeah, but he owns the whole world, so we don't know.
I mean, if I bought myself a 65-foot yacht, I'd have to own an
That's
orphanage.
it. 65.
I have to own an orphanage in
On the
Africa to
boat.
feel better or
On the
something,
boat.
right? Just to feel better about myself.
You'd have to bring orphans onto the boat.
That's why you get a 200.
Yeah, I just have to-
It definitely justifies it.
when you use
Yeah,
to balance that.
And if they turn out bad, you just throw them off the boat.
Yeah.
Wow, we're just going, I was going to say off the deep end, man.
You kids are awful.
Wow.
Don't get chummed. Get chummed.
All right, so let me go through some example architectures here, because if you Google this, they're everywhere. MVC is incredibly popular, but let me give you some 4 more examples. I just showed you one with Java FX, so here's some more. First off is MVC structure or J2EE. You can also do this with .NET. When you go on program, chances are most of you will be looking at something like this, where you'll have in the browser, let me use my mouse pointer, the user puts in a request, the controller gets that request, maybe it's a login request, he goes, whoa, login request, hey, model, Java Bean or whatnot, can he actually log in with this? And then, goes in, finds out, says, hey, look, view, you're going to get an update. The model either comes back and says yes or no, and then it responds back to the browser. So controller says, okay, his request is username, login username, password. Let me go tell the model, hey, can I do this? Hey, view, you're about ready to get an update. Model goes in with the database, gets some information, pushes it back to the view. The view eventually sends the response. Everyone good with this? Because you'll be literally, when you're looking at code, part of the class name will be controller, model, and view. Hey, it's a little off. So Qt, which is a C++ GUI rendering mechanism. The only difference here, what is different here? Quick, anyone?
Delegate.
Instead of,
Control.
yep, that's about it. So you work with the delegate, aka the controller here, and then it can, tells the model to change, which will update the view. Of course, the view in this case is also the button they're clicking on, so that's why there's an arrow going to the delegate. Swing, previous version of Java FX. See, what do we got? Let's read the slides. View gives you a presentation of the model. The view usually gets the state and data it needs from the view to the display directly from the model. Yep.
Controller takes user input and figures out what it means to the model. Oh, that's a good way of putting it. Clicking on this button means we need to log it. All right.
Here's the creamy controller.
Where's the creamy controller?
That's what it says.
It lives in the
Here's
middle.
it lives in the middle. And the model holds all the data, state, and application logic. The model's oblivious to the view of the controller, although it provides an interface to manipulate and retrieve the state. Why do we want the model to be oblivious to the controller and the view? This is a beautiful question.
It just does the work.
It just
just
holds
does
the
the
data.
work.
It just holds the data.
Yeah, it just does the work. It's the worker. Doesn't need to worry about anything else. Why is that so important on Macs?
Because it resembles a computer program. Do the work.
It keeps us from having to change everything else after one thing.
Okay, yeah, it helps with roles. Yeah, changing. Maybe if it's only in the back end, you only have to change in the model. Oh wait, it's a GUI problem. Okay, that's with the view, et cetera, et cetera. So yeah, it helps you with separating work.
Single responsibility.
Yeah, single responsibility. Yeah, this is really just single responsibility principle to the extreme. All right, how about another example? What if you had your code and we'll say instead of Java it was C++ and it could only work on Linux with their GUI system, and all of a sudden you wanted to port it to Windows? What would you have to change?
Probably the controller.
The controller and the view, but you wouldn't have to touch the model. So you've helped separate, basically make porting easier. Another example going from PS3 to Nintendo Switch, Xbox for now. Same thing. And lastly, before we get too far, I do want to explain that when you have a program, this one introduced Observer. When you have a program, notice the models are on the right. You may have a hierarchy underneath your view, your controller, and your model. Over here, they're using Observer, which is another type of view we haven't really talked about. But don't worry about that. All right. Oh, this is the best 20-minute presentation ever. So a model does the business logic. You'll hear that term sometimes. They're actually doing, the business logic, the work. And it should be I/O free, aka no GUI. Communicates to the model. Communication with the model is via methods, right? This approach gives maximum flexibility to have models used. We just talked about porting, for example. The controller organizes the program and provides input and control. Notice over here the controller was probably the longest, but it was really just a bunch of organization of how do you organize things. The action event was really just one function call, and that's really what it should be inside the controller. It should be one simple function call to everything, but it basically provides an entry point so you can see where everything is going and being able to group it together. The view displays what's going on. It basically just reports back. It should never display what's going on it should never display what's going on in the model. It only responds what the model has done or finished. It's basically displaying the finished work from the model. In other words, you don't care how it's sorted, you just want it to be sorted. So you don't need to watch it being sorted, you just need it to be sorted. Another one is if you want to save a file, the view shouldn't tell you if that file's been saved, it just tell you what the model tells you. Because the model is going to actually figure out if it succeeded or not. The nice thing about that is if you want to change from saving to a file system to saving to a remote database, it's still the same code. You don't have to change the view. You just have to change the model. And lastly, in small programs, the view and the controller are combined. All right, any questions about this? Well, I said if time permitting, we can do a longer example. So I guess that's the situation. One more time with more enthusiasm.
All right.